Today we're going to factor some special cases. The first case I want to talk to you about is called a perfect square trinomial, and you need to be able to identify it. And so sometimes when I start to factor, if I don't recognize it's a perfect square trinomial, which I usually won't, you can always just factor it the long or short way depending on if there is a coefficient of x squared. However, if you do notice that it's a perfect square trinomial, then it does make it pretty easy to factor. Okay, so if you look here, I know this kind of looks a little confusing. So this is an example of a perfect square trinomial. The first and the last term are perfect squares because the coefficient here is a 1. This has to be a positive. And then the 14 is the square root of a and the square root of c multiplied by 2, okay? So to see if it's a perfect square trinomial, I basically start off and say, is that a perfect square? Yes. Is that a perfect square? Yes. Then I square root. The square root of 1x squared is 1x, so I have 1x, times the square root of 49, which is 7, which gets me 7x. I double it, it gets me 14x. So this is an example of a perfect square trinomial. Now, sometimes it's such a hassle to see if something's a perfect square trinomial that I just go ahead and factor it the long or short way. Okay, so the nice thing about it is that they're easy to factor. So the headache in these is figuring it out if it is a perfect square trinomial, but once it is, it's really easy to factor it, okay? So let's start here. Is this a perfect square trinomial? Is that a perfect square? Yes. Is that a perfect square? Yes. Oh, it's the same problem. So we know that this is a perfect square trinomial. Easy to factor. To factor it, you just square root the first guy, square root the second guy, and you use this sign in both of them. Okay? Let's look at the second one. Is this a perfect square trinomial? Is this a perfect square? Yes. Is this a perfect square? Yes. Square root the first guy, square root the last guy. 3x times 5 is 15x, doubled is 30. And you don't have to worry about this sign right here. Okay, so yes, it's a perfect square trinomial, so really easy to factor. Square root the front, square root the back, and use this sign. All right, I wanted to talk to you about something like this because, this actually is a, let's see if it's a perfect square trinomial. So right here, is this a perfect square? Yes. Is this a perfect square? Yes. The square root of 4 is 2x. The square root of 9 is 3. 2x times 3 is 6x. Double it, I get 12x. Yes, it's a perfect square trinomial. Factor it really easily. Okay. So if you know it's a perfect square trinomial, it's very easy to factor. All right. Now the next part is going to say, well, what would make this a perfect square trinomial? And this is going to be helpful a little bit later on, but it's a good thing for us to practice. Okay, so we have this front part and we're trying to figure out what does C have to be in order to make this a perfect square trinomial. Okay, so we're going to kind of think going backwards here. All right, so this is a perfect square. This needs to be a perfect square. And then when I take the square root of a and the square root of c and double it, I get 24. Okay, so this is kind of how I start off. I say, well, let's undouble this. Let's divide this by 2. And I'm going to get a 12. All right, so when I multiply my a times the square root of a times the square root of c, I need to get 12. So this is 1. So 1 times 12 gets me 12. Well, now let me square 12, so c needs to be 144. And I can double check that real quick. The square root of x squared is x. The square root of 144 is 12. 12 times 1 doubled is 24. Okay, start over here again. This is a perfect square. We're trying to figure out what does c have to be a perfect square trinomial. So I'm going to go ahead and say, well, I need it to be half of 12. So I'm going to write a 6 here. I need this to end up being 6. The square root of 9 is 3. The square root of, so 3 times what number is going to get me to 6? Needs to be a 2. The square of 2 is 4. Now I could double check that. The square root of 9 is 3. The square root of 4 is 2. 3 times 2 is 6. Doubled is 12. Okay? Now, if you notice this one, it's a little trickier because you start off and you say, wait a second, this is not a perfect square. And to be a perfect square trinomial, the first term needs to be a perfect square. So what I'm going to do is I'm going to say, well, I wonder if I factored out a 5 here. If notice that's divisible by 5, that's divisible by 5. So if I factor out a 5 and I get x squared minus 6x plus, well, I'm just going to put c for right now, and we're going to have to recalibrate in a minute. Okay, so let's just look in here. We're going to ignore that 5 for a second. All right, so I'm trying to get this to equal the a times the c doubled needs to be 6. So I need for this to be 3. The square root here is 1. So I have 1 times 3 is 3. Now when I square, that means this needs to be squared. So that needs to be 9. So my c in here needs to be 9. But remember, this was the original question. So if this is a 9 right here, if my c is a 9, when I redistribute this 5, that's going to end up being 45. So a little bit of, you had to pull out the GCF to really see what was going on to make that a perfect square trinomial, and then redistribute the 5 back. Okay, so I always think that I like to show a real life problem, and this one seems a little more complicated than it is. It tells me that the volume of a cylinder is pi times this, and that's just inches. So I'm going to kind of ignore that, inches, because I don't want you to think that it's an I and an N variables. All right, it tells me that the height of a cylinder is 3, which is starting to confuse me a little bit because I know the volume of a cylinder is pi r squared h. And I'm thinking, well, I see the pi here, I don't see the h, and I have this, and it's asking me for the radius. Okay, so the first thing I'm going to do is say, well, let me factor it. Well, let me see. Is this a perfect square trinomial? Is this a perfect square? No. Okay, so let me see. Well, 3, there's a GCF here of 3. Okay, so I'm going to bring this pi down, and I'm going to factor out a 3, and I get 9x squared plus 6x plus 1. Okay, now is this a perfect square trinomial? Yes, that's a perfect square. That's a perfect square. The square root of 9 is 3. Square root of 1 is 1. 3 times 1 doubled is 6. So this is a perfect square trinomial. So if I just wanted to rewrite this, I like to put the number first, 3 pi, and then I have, remember now it's easy to factor this. 3. And I could just say 3 pi since those are the same thing. Okay, so since the formula is pi r squared h, right, I can figure out that's pi. This is the r squared, and this is h. So the radius is 3x plus 1. All right. Oh, this is my other page, sorry. Okay, so now I want to talk to you, so that was one sort of case that was perfect square trinomials. The other one that is really nice to factor is called a difference of squares. And it's also pretty easy to recognize it. It's not a pain like the other one. So to find it, the first one is a perfect square, the second one is a perfect square, and you have a subtraction sign. So whenever I see a binomial, I check for that. It's usually pretty easy to see, okay? And what it does is look at the answer. When I have a perfect square, when I have a difference of squares, sorry, I hope I was saying difference of squares. When I have a difference of squares, my answer is the same exact thing, one's a plus, one's a minus, okay? Super easy to factor and pretty easy to recognize. So if I look here, is that a perfect square? Yes. Is that a perfect square? Yes. And do I have a subtraction sign? Yes. So really easy to factor. I just go into my 2 parentheses, square root square root, and my signs are different. One's a plus, one's a minus. Okay? Is this a difference of squares? Perfect square, subtraction sign. I can go straight into my answer. Perfect square, subtraction sign. So I really like these. And it doesn't matter if you put the minus here and the plus here. Okay, now these are a little trickier problems, and they say factor completely. And so when you look here, the first thing that you're going to notice is there's a GCF here. Not only is there a 4 as a GCF, there's an x. Okay, so I'm going to factor out 4x. All right, and mainly because of this section, I'm going to see, did I do this wrong? Oops, I did this wrong. There we go. Okay, I'm going to say, is this a perfect square trinomial? Well, the square root of 1 is 1. The square root of 9 is 3. 1 times 3 is 3. Doubled is 6. So this is a perfect square trinomial, which is great. So now I can factor it really easily. And then, sometimes people write the answers like this, which is totally fine too, right? Same thing. Okay, last one. Let's see, is this a difference of squares? Well, that's not a perfect square, that's not a perfect square, but let's see if there is a GCF. 2, let's see if there's a bigger one. That gets me 25x squared, so that's a perfect square. 16. All right, so I factor out my 2, and now that is a difference of squares. So it's really nice and easy to factor. 5, just square root both sides. And use a plus and a minus. All right, so it's kind of nice if you're in a section. Remember, if you don't notice that something is a perfect square trinomial or a difference of squares, you can always factor it like what we've been doing the whole time. Okay, have a good day.